MCV 41, Unit 13 bonus video. So page 146, number 10. Determine the area of the largest rectangle that can be inscribed inside a semicircle with radius of 10 units. Place the length of the rectangle along the diameter. Okay, so the first thing that we want to do, we want to draw a diagram so that we can visualize the problem. So here's our diagram. So here's a semicircle, the length of the radius, the length of the rectangle is against the diameter. And so we're going to let y represent the width of the rectangle, and we're going to let L represent the length. And it's important to note that the length equals 2x. So what we know is that this semicircle has a radius of 10 units. Just pause. Okay, so what we know is that this semicircle has a radius of 10 units. So that means from the center of the semicircle to any point on the circumference, that distance is 10 units. All right. We also know the formula for area. So area equals length times width, which would be the same thing as 2x multiplied by y. And then now what we need to do is we need to get the formula for the area in terms of one variable. We only have, right now we have two variables. So what we're going to do is we're going to use Pythagorean's theorem and do x squared plus y squared equals 10 squared, which is the same thing as y squared equals the square root of 100 minus x squared. So now we just expressed y in terms of x. And then from here we can establish a formula for the area in order to get a maximum area. So what we're going to do, we're going to write our equation out again. So area equals 2x multiplied by the square root of 100 subtracted by x squared. So now we want to differentiate that and set it to 0 so that we can have a possible maximum value, because when a prime equals 0, that'll be a horizontal tangent on A, which means that it'll be a hill or valley. In other words, it'll be a maximum or minimum value. So then once we differentiate it, you end up getting this value right here. So a prime equals 2 multiplied by square root of 100 take away x squared plus negative 2x squared over square root of 100 minus x squared, and then we set that to 0 and we solve for x, and we end up so we just basically we're simplifying it and just isolating for x, and you end up getting x equals root 50. So now we have a value for x. Okay, so now we just established that x equals root 50. So when we plug that into our Pythagorean equation, x squared plus y squared equals 100, we get x squared, so square root of 50 squared, which is just 50, plus y squared equals 100. So what we're doing right now is we're trying to solve for y. So that ends up being y equals square root of 100 take away 50, which ends up being y equals 5 root 2. So now we can determine our length, because now we know x. So length equals 2x, which equals 2 multiplied by root 50, which equals 10 root 2. So the area would be length times width. Here's our length. Our width is y, so 10 root 2 multiplied by 5 root 2, which equals 100 units.